Hey guys, it's Clint Garrett, Ace Networker, and I want to welcome you to this video where we're going to be talking about bridging versus switching and why we used to use bridges and why we now use switches on computer networks. Now, this is the first video I'm going to be going through a long series just talking about network switches, and when we're done with that series, when we've gone into some in-depth detail about network switches and how they work, to get you up to date on being able to pass the Network Plus exam, at least, probably better. Maybe the next certification like CCNA or CCNP perhaps. We'll see. We're going to get you up to that level, and we're going to go through this series on switching. And once we're done with switching, we'll then move into routing. So with this first video, we're going to talk about bridging versus switching, why bridges are seldom, if ever, used anymore on computer networks, why we use switches, and why we have what we call multi-layer switches now. Some layer 3 or layer 4, they call them, switches, can actually function much like a router on a smaller to medium-sized network. So let's get into bridging versus switching. Are you ready? To begin our exciting journey into the world of network switches and switching on computer networks, we have to first go back into really recent history. Okay, we're not talking about that much history, we're not getting that in-depth, we're just talking about 30 years ago, 3 decades. In most cases, when you're talking about IT, it advances so fast that really you're just talking about a few years. Or in a lot of cases, when you're talking about a lot of different technologies, you're talking about just a few months. So we're going to focus on bridging versus switching in this short video. But to understand bridging, we have to go back a little bit in the history of IT to why bridges were developed and used. And to understand that, we have to show how hubs originated and were used. And I'm going to go over that history really quickly and really fast here so we can immediately get to where we are now with technology. Now, if you haven't watched it, you're welcome to watch this video on hubs and how they actually work and why you don't really find them used on networks in the present day. Real quick, in the early days of computer networks, you would have what were called mainframe computers. You would then have controllers connected to these mainframes, and off of those controllers, you would have dumb terminals. They used to call them dumb terminals. These were where the end user or users would actually access that mainframe computer and everything on it. And a dumb terminal really was just a monitor, a keyboard, a mouse, and just enough equipment to communicate with that mainframe over that connection, unlike the PCs that we have now. Now, it's important to understand these mainframe setups because at the time, to allow remote sites to connect to the mainframe computer, they would need bridges. And it's important here that you get that this is where the network bridge was originally developed and used. I'll come back to bridges shortly coming up here. So eventually, that mainframe setup morphed into what we now refer to as a collapsed backbone network, like the one shown here. It was called a collapsed backbone network because hubs were developed and used to connect PCs, which were quickly on the rise in stardom, in fame and stardom at the time. To connect these PCs directly to the corporate backbone, they would use these hubs. They would connect these PCs to the corporate backbone to reach any network servers or other services or devices on that network. Again, if you watch the video I created on hubs, you'll see why they couldn't keep up with the demands for use that we humans require of computers and networks, especially by today's standards. And really these days, I'm not trying to be cruel or anything, but hubs these days on today's networks with the demands that are needed on today's networks are about this useful. But hubs were used at the time because they were the only thing available for connecting multiple PCs to a computer network at the same time. There's also a lot of history on how the servers on those early collapsed backbone networks ran off of token ring connections and didn't function like netware servers do now. And I may create a video talking more about the history of those technologies too in the near future. Suffice it to say, you don't need to know all of this history to pass the Network Plus certification exam, at least not yet. The key thing to keep in mind about these corporate collapsed backbone networks is that they grew and grew and grew, and as they did, network services became slower and slower. This is very similar to congestion of traffic in major cities. When you look at a major city and you have major traffic congestion, if all you had were major freeways, like when you just have big routers and then they have to immediately exit off into a neighborhood, you don't have something in between. So that's where switches will come into play. There are multiple reasons this happened. The biggest of those was that LAN services were needing faster service. Software demands from new and innovative software applications needed more bandwidth and usage by themselves, and networks were becoming saturated and bogged down. This is where bridges come back on the scene. Bridges were used to break up collision domains to help handle that saturation that was occurring on those networks. However, there were some limitations. Bridges have a limited number of physical ports for use on their physical hardware, and bridges cannot provide the network services needed to handle everything. Layer 2 switches helped save the day by breaking up collision domains on the network into a separate collision domain for each physical port on the switch. The real benefit to Layer 2 switches arriving on the scene was that they could provide hundreds of ports instead of the limited number of ports available on bridges or on a bridge. So those early networks began to morph into something like this. You would have hubs connected on each port of a switch to allow more devices, typically PCs in most cases, but this would allow more devices to connect in each area of the network. And that's the first and primary way that Layer 2 switches started being used to solve the problem of ever larger growing networks and saturation of those networks. Now, this leads us to the other big reason why Layer 2 switches replaced bridges on computer networks. Bridges were designed to use software to create and manage a filter table in their own memory for making decisions about network traffic that arrived on their physical ports. Layer 2 switches, on the other hand, used ASICs. That acronym stands for Application Specific Integrated Circuits. Layer 2 switches use ASICs to create and manage their filter tables. Now, I'll stop right here and remind you that it's still okay to think of a Layer 2 switch or Layer 2 switches as multi-port bridges. That's because they both break up collision domains, but the efficiency of Layer 2 switches compared to bridges, and the fact that switches offer a lot more physical ports for connecting devices than bridges do, shows why switches won out over bridges, and still do to this day. I also want to inject here that Layer 2 switches and bridges are much faster than routers when we get into those in later videos, because switches and bridges don't have to examine the network layer header information at the beginning of a packet inside each frame. They simply look at the frame header, source and destination MAC addresses, and they make decisions to either forward the entire frame or drop it based on that information. Last, but certainly not least, is the fact that both bridges and switches could use the loop prevention protocol known as spanning tree or spanning tree protocol. But the real key here is that only one instance of spanning tree can be used on a bridge, whereas multiple instances of spanning tree protocol, better known as STP, multiple instances can be used on a Layer 2 switch. I'll get more into detail about spanning tree as we go along. In fact, if you haven't watched this video yet, I'd invite you to watch it, where it talks about what spanning tree is and why you have to have a loop prevention protocol like spanning tree to prevent your entire network from locking up and no longer passing any traffic, because that is a possibility if you don't have a loop prevention protocol like spanning tree running. Remember that bridges are software based, while switches are hardware based. They use the ASIC chips to make their forwarding decisions on a switch. Also remember that a switch can really be thought of as a more capable multi-port bridge. You can have a lot more physical port connections on a switch than you ever did with a bridge. Remember that bridges can only run one instance of spanning tree protocol, while switches can typically run multiple instances of spanning tree protocol. Remember that bridges and switches forward Layer 2 broadcasts, and I'll get more into broadcasts in future videos, so we'll go over those. Bridges and switches learn MAC addresses from the source address on each frame that arrives on an inbound port, and really, last but not least, is that fact that bridges and switches both make forwarding decisions based on Layer 2 addresses. So that summarizes the differences between bridging versus switching. And it's the perfect intro video for us getting into switching and talking about network switches, and the layer 2 level of the OSI model, because layer 2 is typically where you're dealing with local area networks and keeping everything local on a local area network. So the technologies that are involved in this series, I'm probably going to get into a little bit more depth about switches and switching and layer 2 technologies on computer networks than what is required of you in a Network Plus exam certification setting. But I want you to be more than prepared. So what I'm doing is I'm going to be going through a series that will really kind of get you up to a CCNA level certification. Okay? So with that said, thank you so much for watching, and I will see you in the next video. Are you ready?